Hi everyone, thank you for tuning into our video. This is our senior design project for the ECE team.
This project goes back 2 years ago when ECE first teamed up with UConn seniors to integrate automation into its assembly process by utilizing a collaborative robot. These teams were first tasked with identifying which of ECE's assemblies were best to automate and then developing a workstation design for the assembly process of the best candidate. The next tasks were to fully integrate the design and program the cobot to perform the assembly process with almost no human involvement. Currently, the cobot is capable of fully assembling ECE's gearshaft subassembly in a matter of 8 seconds per part. This year, ECE has given us the task of automating the next best candidate, which is its rack bearing subassembly. This subassembly is a component of the mounting rig on an actuator control system. The part consists of 2 pieces, a black plastic rack bearing base piece and a metal support rack top piece that are held together by 2 3x16 screws. This assembly utilizes the die that allows a worker to assemble 6 of these parts at a time. To begin the assembly process, the worker places 6 of the plastic pieces face down into the die and then puts a metal bracket on top of each one with its side of 2 holes facing the worker. Once the 2 pieces are aligned, the worker uses a screw gun to screw the pieces together. Once all 6 parts are assembled, the worker dumps them into a bin and repeats the process. Figuring out how to automate this process was a big challenge for us in the beginning because of the complexity of the process's screwing portion. Eventually, we decided to go with an off-the-shelf solution. Essentially, the solution is a screw-driving package for the cobot that includes a screw feeder to deliver the screws in the same orientation and a screwdriver for the cobot with a built-in vacuum to pick up the screws from the feeder. To smoothly transition from the screwdriver to the cobot's existing grippers that will be used to grab the plastic and metal pieces and then drop the final product in a bin, a 45-degree dual mounting plate was added to the cobot's arm. Like the manual process, the cobot puts together the subassembly using a die. The die that the cobot uses only holds 1 subassembly, however, as we determined that it was more effective than holding 6 parts. To deliver the plastic pieces and metal brackets to the cobot, we integrated part feeders into the workstation's Bosch tubing. The only human involvement necessary is for the worker to load the plastic and metal pieces into the part feeders and to empty the bin of completed assemblies. The cobot was coded with the aid of this flowchart that maps out the required movements for the entire assembly process. The coding was done with the interface that is equipped with the cobot, which uses drag and drop programming. The cobot screw-driving package comes with a module that can be added to the interface, which gives the cobot the capability of picking up the screws and screwing them into the parts at a specified torque. Here is the automated assembly process in action.
If you're trying to rotate it so
Throughout the project, we were constantly able to increase our efficiency. In our first iteration, the cobot put together a single subassembly in 52 seconds, and by our last iteration, this was cut to just 25 seconds. None of our efforts were able to beat the cycle time of the manual process, however, our final iteration significantly increased process capacity. These are the results that ECE was looking for, as it emphasized that speed was not the objective, but rather to free up the operator's time for other parallel tasks. ECE simply wants to cut down on the amount of repetitive assembly motion operators have to increase ergonomics and decrease workplace injuries. That concludes our 2022 Senior Design Project sponsored by ECE. Thanks for watching.